I always look at this little red dot that comes up. Okay, and welcome to a Monday. Da, 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 da. We have homework here from 6.3, and I'm going to go through it. So 21. Use a graphic calculator to find all the degree solutions from 0 to 360 for each of the following equations. Let's jam. Let's go for it here. It says use a calculator. This one you probably would be okay even not using calculator. I know when cosine gives me a 1/2. Cosine is an x coordinate. It's going to be closest to the y-axis. So I'm looking at a 60-degree angle. True, true. And I'm looking at a, nope, that's going to give you a negative, huh? Nope, not quadrant 2. How about quadrant 4? All right, then I'm looking for that angle right there. I'm thinking 300. You guys okay with that? Okay, I guess let's do this here. Let's go by calculator real quickly here. Options, nope, screen. There we go. So let's go over here just so we have it, since it is 300. Sorry, yeah, 300. So let's go with turning on your calculator, go to the mode and make sure you are in degree mode, and make sure you get out of parametric equations. That would be great from Friday's class. So go back to function mode and degrees.
So being in the parametric equation, like setting, alter the numbers you get when you're just like typing in numbers, or is it just when you graph?
I think it's just when you graph.
Okay.
Yeah, I'm pretty sure. Yeah, because you can still set things. So degree mode, just to get so we know where we're at. All right, I'm looking for, here's what happens on the calculator here. If I'm looking for this, I'm technically looking for 3x is equal to cosine inverse of 1/2. We good? So with the calculator, you always want to make this guy to be a plus sign. You want to have something called the, come on, theta hat. Remember that? It was the reference angle. Reference angle you want always in quadrant 1, because once you put it in quadrant 1, you can do the rest of them out of that. Okay, so I'm going to go with cosine inverse, second function, boom, and 1/2 or 0.5. Either one is just fine. And you should get that little guy right there. Once you do that, then the rest you have to calculate depending which quadrant you need to get to. Okay, are we good there? Let's see. So I have myself, what did we do? We got to the end of chapter 6.3, yep. So we do this one right here. We just say 3x is equal to 60 degrees plus 360 degrees K. That's one answer. The other answer is 3x is equal to 300 degrees plus 360 K. And so for our x values, we get this right here. We get x equal to 20 degrees plus 120 degrees K. And so here as well. This one worked out nice. It's 100 degrees plus 120 degrees K. And all we're going to do is we're just going to do 3 iterations of K. So I need K is equal to 0, K is equal to 1, K is equal to 2. And I'm going to get all my answers. Does that make sense? So if K is equal to 0, right over here, this is 20 degrees. For K is equal to 1 right over here, what do you guys say, 140 degrees? And then K is equal to 2. 240, I think it's 260. Everybody agree there? That's for this top one here. Going to the bottom one now here, if K is equal to 0, it's 100 degrees, 220, and let's see, 240 plus, that'd be 340. Bam, I got all my, there's 6 of them, and I got all 6 answers. Make sure that Bob agrees with us. Hopefully Bob agrees with us, or no? Anybody check with Bob yet? No. Adrian with a slight, it was like almost a yes. It's like, ah, yeah, I checked with Bob. Yeah. Oh yeah, he's cool. Okay, you guys talk to me here. Does that make sense of how to do it now that we do the K values? All right, let's jam with 41. Cosine theta minus sine theta. And here's where we get stuck. Rounding your answers to the nearest tenth of a degree. That means I'm going to use my calculator for sure. And I see a cosine function, I see a sine function. They're both linear. There's no square on it, so I can't use Pythagorean theorem. So I'm stuck. I am going to add sine theta to both sides just to get one of the trig functions by themselves on one side. Good there. And I'm going to square both sides at this point. Talk to me. If I square both sides of an equation, what do I have to do?
Check it out.
Gotta check all my answers after this. Okay, so cosine squared becomes cosine squared. This guy off to the side if you need to. Dun, da, da, dun, da, da. Root. That's gonna be 1. That's gonna be sine theta. That's gonna be another sine theta. So now I have 2 sine theta. Tell me if I'm going too fast. I can always slow down. I can always speed up too, but that'd be kind of funny. Okay, so now I'm looking at this here. I'm getting better. So I'm looking at saying I have a cosine squared, I have a sine squared, but this guy right here, here's my little issue. Notice that sine theta is still a linear form. So if I'm going to use the Pythagorean theorem, I'm going to use it on this guy because I'm going to make everything into just sine. So getting a little closer, I have everything in terms of the sine function. Cool. Let's go with it here. Let's see. I'm going to subtract 1 from both sides. I'm going to add sine theta to both sides. Good morning. That goes away, and you guys make sure that I don't make any funny mistakes here. Are we good there so far? Factor out a 2 sine theta. That's what I would do. I'm left with 1 plus sine theta. And now I have 2 sine theta equals 0. And sine theta plus 1 equals 0.
I did it a different way.
Uh-huh. Talk to me, let me finish up and then let's see, and then ask me after that. That'd be no problem. Okay, I got these two here. Let's see, unit circle. I got myself sine is equal to 0 at 0. Sine is equal to 0 at pi. And then sine is equal to 0 at 3 pi over 2. Those are my 3 little possible answers at this point. So now I can just plug it back in. If I plug it back into the original problem. I think we can we do this in our heads maybe? 0 plugged into here and here. Sine of 0. So theta equals 0. Sine of 0 is 1, I think. Is that right? Oh yes, 0 works. Everybody agreed there? Because sine plugged in a 0 into here. So cosine makes a 1 at that point. Sine makes a 0, and 1 minus 0 is still 1. That checks out. Okay, how about theta is equal to pi? Pi plugged in gets me cosine of pi is -1. Sine of 0 is still 0, and that does not check out. Okay, then how about theta is equal to 3 pi over 2? Dun, da, da, da. Okay, this little guy, that is going to be 0, -1. So cosine is 0, sine is -1. At this point, it does check out. Sorry, writing chicken scratch here. Boom, jamming. Okay, I like this. Theta is equal to 0. And 3 pi over 2, except I'm making mistakes here. Because on the instructions, of course, you guys just let me do it, huh? Just like let Mr. G do it all the way to the end, and then he realizes a mistake. And then you got this internal ha 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 ha, ha, right? Because we're supposed to be in degrees here, so the thing we got to change is pi is 180. That's 270. And the ones that actually work are 0 degrees and 270 degrees. We don't do the 180. Okay, Karina, yours. Which way did you go about doing it?
I started by just squaring both sides before moving the sign over.
Okay. Sure, let's go for it. Let's take a look at it here.
But now I'm looking, and I only got 0 degrees and 180 degrees and not 270 degrees. So, yeah. But I don't know why.
Gotcha. Let's see. The reason why we do it this way, and then let's try it the other way, is we are able to use the Pythagorean theorem afterwards, right over here. And so if we solve for one trig function, once we have that in place, the rest of it should work out. It's the same thing in algebra 2. If you guys remember when you guys used to solve for square root functions, you had to solve it for one of them on the side and then square both sides. But let's.
We don't have to do it my way.
Yeah, okay. It'll be interesting to see. So I'll do it after class. Just to sort of see. Okay. Tell me if everybody's okay with 41. Anybody need more time with 41? Going once, going twice. Sold. Okay. $45, $49? Ooh, same concept here. It's in the same directions here. So sine squared. I got 2 theta on my hands. Minus 4 sine 2 theta minus 1. Okay. I guess the question is whether this guy is going to factor or not. Or go back to algebra. Let's see, x squared minus 4x minus 1. Does that factor in algebra terms?
There's 2 there. X minus sine squared 2.
Perfect. So this is a sine squared. The 2 theta is because of the angle measurement, not because there's a 2 multiplying sign.
I don't think it factors.
I don't think it factors. No, 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 no. Okay, so we got to go to this and we got to go to factoring. Sorry, factoring doesn't work, so we have to go to the quadratic formula. So I'm going to go with negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, this is a fun one to do. Let's see, inside the square root, I have myself 16 plus 4, so that's 20 over 2. That becomes, let's see, 2 root 5 over 2. And I can reduce each of these guys by 2. Oh, that's nice. The denominator goes away. I'm left with 2 plus root 5, 2 minus root 5. This is going to be fun. All right. Whoever has a calculator that can work this with me here, can you guys give me what's the approximate value for 2 plus root 5 and then 2 minus root 5? Let's see which one's even work.
2 plus root 5 is 4.2. 4.
Gotcha. Okay, what do we know about that guy?
It's more than 1.
More than 1. So that's not going to work. That's cool. Thank you, Hayden. How about 2 minus root 5?
Negative 0.236.
Negative 0.236-ish. Okay. All right, that's the one we're going to concentrate on, and it's negative, of course, just to make our lives just more enjoyable. So let's go with it here. So first things first, in my mind is we're in degrees, correct? Sine is negative, which 2 quadrants?
3 and 4.
3 and 4. So I might as well set that up already. Boom, boom. Okay. Next is I'm going to take the inverse. So let's bring everything down here real quick here. So this is sine of 2 theta is equal to 2 minus root 5. That's what we're solving for. So 2 theta is going to give us sine inverse of 2 minus root 5. Ooh, hold on. We got a little problem. That's going to give us a negative, huh? So here's what we do in the calculator. Because we still want a good approximation. So, come on, calculator. Ding, ding, ding. Oh. I don't know. Oh, thought it ran out of batteries for some reason. Okay, 2 minus square root of 5. It's a Monday joke.
I was like, wait.
Okay, I got that one. So what I want to do is I want to actually make it into a positive. So it's going to be negative of my answer. Are we good? Enter. Are we good there? So you get a negation, and this little guy over here, ANS, answer. It'll always bring in the previous one. We have sine inverse of, now let's bring in the answer again. And this one's going to give us our reference angle in quadrant 1, right? Because that's what we want. To the nearest 10th. That's what I'm looking for. So 13.7 degrees. 13.7 degrees. Okay, so that means I'm looking for an angle here of 13.7 degrees. What will that be? 180 plus that, 193.7? 193.7, okay, I got that one.
Wait, why is it in quadrant 3 again?
Because sine was negative to begin with.
Okay.
So then I need, let's say I need quadrant 4, which is 360 minus 13.7. What is that, anyone?
Um, 346.3.
346.3. Cool. Okay. Running out of space, but I think we can still do this here. So I have myself 2 theta is equal to 193.7 degrees plus. Right, we still have that little deal to work with. Then I have 2 theta is equal to 346.3 plus 360K. So theta finally is this right here. Help me out, please. 193.7 divided by 2.
96.85.
Plus 180 degrees K. Okay, got that one solved. And then this one, divide by 2, divide by 2, divide by 2. And I got myself 346.3 divided by 2. $170.
173.15.
Okay. Okay, I think we're almost there. let's go with it here. So theta is equal to 96.9. Is that okay? Did I do that one? Because it's the nearest tenth anyways. Then add 180 to this guy. Anybody help me out with that? 96.9 plus 180.
276.
176?
276.
276.1. Okay, keep on going here. I got 173.
I think it's 276.9.
9, thank you. Right. All right, I got 173.2 from this one, and then I need 173.2 plus 180. Okay, perfect. Okay, are we good there? That one's a toughie. These guys are actually tough in 6.3. So glad you guys wrestled with them a little bit here. And then the rest of it is just us putting things together here. Okay, 49. Anybody need more time with 45? Okay. What do you guys say? Chill Monday, or you guys are just falling asleep Monday? Which one? Both, okay. Boom, okay. Let's liven things up here. I'm not gonna just go down the rows here. Whatever you think is the next step. So Corinna, start with you. Go ahead. What do you think we should do?
I think we need to turn the cosine into a sine.
Perfecto, yep, because we have a sine that's a linear form right here. Absolutely, there's your linear form of sine. So the other guy gets to change. Boom. Okay. Theta plus this, all that happens. That's easy. I can do the rest here. I can distribute the two. All right, Hayden, I'm going to bug you next here. What is the next step after that? We've got everything in terms of sines now. I see a sine squared, then I also see a linear sine form as well.
Would it change anything if you put it in terms of x?
Say again, say again.
Would it change anything if you put it in terms of x? That's the only thing.
Right before we factor, yeah. So let's set it for factoring. I think that's what we want to do. Cool. Or how about this? Starts with F and ends in actor. Boom. There you go. So I'm going to set up for factoring. So I'm going to move this little 2, let's see, all the way to the end over here. So plus 2 over here. I got to add my subtract the 1 now. Okay. Amaya. Next.
I tried it and I don't think it's factorable
Ooh, okay.
easily, so I think we should do quadratic formula.
Gotcha. Okay. Yeah, the only thing I would do really quick just is get rid of any negatives in front. I'll probably just multiply through by -1 everywhere.
Can you do it with the negative in the front?
You can, just the multiplication gets a little iffy, and then you got to do guess and check to make sure the signs work out nicely.
Okay.
That's the only problem. Okay, so Amaya said this is probably not factorable. This is where I kind of use this little thing right here now. So the question is that possible to do? There's my little x's. Let's see, the only way to get 2x squared is 2x times x. That's the only way there. Only way to get a -1 really is and also get a negative inside the middle there.
Minus 1 plus 1.
Might as well plus 1. And if I do any of that, notice I'm going to either subtract, I'm going to get 2x minus x, or I'm going to get negative 2x plus x. So there's no way to get a 2 in the middle. Impossible. That's when I checked to make sure I didn't do any silly mistake. I don't think so. Anybody know the answers for 49? Is it going to be all not so very nice?
I did the quadratic.
There's one?
Yeah.
Okay.
Yeah, it is, they're not.
Okay. So I got sine. This time it's 4 theta. Oh boy. 2 plus or minus b squared minus 4 times a times c all over 2 times a. Let's see if I can squeeze this right into the bottom here. Inside the square root. Anybody help me with that? Oh, Haley, check that out. Can you help me with 4 minus 4 times 2 times negative 1?
Well,
12 is good by me. Perfect. Boom. And Rylan, can you factor out my 12 for me to get perfect squares out of it?
No.
Other way around,
Yeah, sorry.
So 2 root 3, perfect. And I can reduce these guys here. So by 2 by 2 by 2, and I got myself 1 plus or minus root 3 over 2. Whew. Thank you, Georgia. You're already setting up the calculator. All right. Exactly what I'm going to do. Okay, so I got 2 different answers. 1 plus root 3 divided by 2. I need to know approximation for that. I need to know 1 minus root 3 over 2. I need an approximation for that. Love it. I love it when I can cross stuff out. Okay, cool. And 1 minus root 3 over 2.
Negative 0.36.
Negative 0.36. Bummer. I got to work with something now.
0.37. Yeah, 0.37.
Oh, yeah, sorry.
7, okay. Yeah, somewhere in that range, but I know I got a negative there. I am dealing with sine again. Okay, hey, guess what? We're going to do the same stuff again here. So quadrant 3, quadrant 4. Everybody agreed there? Grant, think you can do that on the calculator there? 1 minus root 3 over 2. You get that answer. Get rid of the negative out of it, and then take the sine inverse of it. So it'd be taking, let me write it in actually the way it would be here. It's going to be the negation of 1 minus root 3 over 2. That's what we're going to be doing.
21.5.
Cool. Okay. Anybody second verify 21.5? Not that we don't trust Grant, but we're going to verify.
I didn't write down. I have it on my computer.
Yes, I verified.
Verify? Okay.
Yes.
21.5, Grant?
Yeah.
Okay. All right. Reference angle is 21.5 degrees. All right, that is the reference angle. We think of it as theta hat instead of just theta. So, Grace, I need 180 plus 21.5. I need the answer in quadrant 3, and I also need the answer in quadrant 4. Sure, no problem. Oh, Adrian, you have a calculator too, huh? Okay, I'll bug you.
I have one, but it doesn't have any like power in it.
Nice.
It's still dead.
Yeah, it's still
Has not been resurrected yet. Okay.
Why does it turn on and off?
Because it has like a slight enough power that it goes up, turn on for a fraction of a second, but they can't use it as a. So, and once I find that charging cable.
That'd be good. That'd be
Is it not
good
just a
sometime.
micro USB? Nice. That's terrible.
What if I can literally die outside the door?
That's just
I will
horrible.
solve.
I will try.
Imagine not just needing like, what,
I should
double A
try.
batteries.
I'm bringing, I'm gonna change the batteries the night before, even if I don't need it, and bring extra batteries with me.
Yeah.
You need water outside.
All right, Grace, talk to me.
What was I supposed to do?
Sure, sure. I need to know 180 plus the 21.5. So I need the angle measurement in quadrant 3. Okay, and then I also need quadrant 4. So that one's a little tricky because that's in quadrant 4. Actually, we're subtracting from 360. So it's 360 subtract 21.5. 338.5. Okay. All right, and I have my 4 theta here. Is that right? Okay, let me get it on the next slide here since I don't have much room. Four theta is 201.5. 4 theta is 339, I believe. Is that right? 338.5. Perfect. Okay. Plus 360K. Plus 360K. Okay, divide this guy by 4. And I need calculators again here. Zachariah, do you have a calculator? Or if Adrian could do it in his head. 50.
Have a head.
You could probably do that. 50. Perfect. Okay. Like that?
Yeah.
Okay. And theta here is going to be 338.5 divided by 4. 2.5, so technically 3, right? Plus 90K. Karina, real quick here, can you give me the answers here? I'll do.
Yeah, I got something different for them. Yeah, I got.
Or for which one? For which one?
The 338.
Oh, gotcha. Uh-huh. Ah, no problem here. So tell me what that is now.
84.6.
84.6. Cool. Okay. 50.4 degrees, and then we have what? Perfect. Okay, then I got the 84.6 degrees, and then 84.6 plus 90.
Wait, what?
Sure, 84.6 plus the 90, because I can get this
Oh,
one
I
right from the
did.
angle.
50.4 plus 180.
Oh, that's right. Sorry. I need to do 4 of these, huh? Because I'm at 4. Okay. Plus 180. Go ahead.
230.4.
And then another 90.
320. Wait.
Yeah, that's what I got.
Okay, yeah.
Cool. Okay.
And then another 90.
1, 2, 3, 4. That's it. Because we need 4 for each one. Because we have k is equal to 0 when we start off with 84.6 degrees. That's the first one.
174.6.
180. Let's see. Add another 90. Will that be 264.6? And how about a 354.6? Are we good? Phew.
Yeah,
I think I'm done for the day. At that point.
So on the test, will there be one that's like, it has 8 different degree answers?
Not 8. That's a
Okay.
little bit too excessive here. Yeah, maybe.
Cause I was like, if you get one of those slightly wrong,
Then you're just screwed.
yep.
Mhm. Mhm.
Which I mean, is like fair, that's why it's.
But situation you didn't agree and you can make it up with the test.
Why?
That's
So-
true.
Let someone else write it out.
Um,
If they really need.
we ran out of time
they
for
can-
51,
they can
53.
figure it out.
So let's do this here. I may write it out and send it to you guys tonight. If not, then we'll just see on when we'll finish up on Wednesday.
Okay.
Okay, enjoy the rest of your day
Yeah, it was-
and enjoy the rest of the week. But I'll see you guys on Wednesday.
Sounds.
Yeah, I was like, I'm pretty sure we're gonna see you like.
What do you know that we don't?